Hi everyone, I'm Ignacio Vellido, and together with Juan Fernández-Olivares and Raul Perez, we have developed a knowledge-based methodology to parse VGDL descriptions into HTN domains and problems. I will start introducing three fundamental concepts in this project. First, we have VGDL, a video game description language that is extremely simple but nonetheless expressive. Again, in VGDL, it is defined by two files, a description of the dynamics and a level up for the game. And the dynamics are divided in four parts: a set describing the objects in the game, the interactions between those objects, the ending criteria, and a mapping of how to read a level description file. This language is broadly used in the VGDL framework, a workbench for general artificial intelligence agents in video games. It features more than 100 different video games in the VGDL standard, with levels of all kinds. And finally, we have HPDL, an HTN planning language. HTNs are a planning variant that encode hierarchical structures, in other words, decomposable group of tasks. That means that they represent different levels of abstraction and alternative decomposition schemes for compound tasks. Now, the methodology we developed proposes a knowledge-based process to automatically generate HPDL domains and problems from the VGDL game and level description, representing the dynamics of the games. With these domains, a human designer can easily include an agent strategy capable of solving objectives in those games. The methodology is structured in three parts. First, we introduce the video game description and the level, and with a parsing process, a set of game entities is extracted. These entities represent elements of the VGDA files needed for the output generation, and are grouped into different categories depending on its relevant information. For example, for an object, we will particularly extract the type and its attributes, and for an interaction, the type and the objects involved. Then, with the help of a set of templates, the entities are instantiated and content for the HTN domain and problem is produced. The templates encode knowledge of how to represent the different VGDL elements into HPDL content, like primitives, predicates, or objects. They are not game-specific, but rather associated with a particular game entity. For example, for an avatar who moves horizontally, we will have templates for both of its possible movements, and in the domains, two different primitives will be produced. Additionally, we include a module of integration in GVGAI to confront non-determinism using replanning and acting. This module, defined as an agent in the framework, grabs the actual turn representation in the game and repeats the parsing process, producing a new HPDN problem. As we are working with HTNs, the domains need a general structure. Therefore, we try to mimic the turn representation in the games, introducing a high-level task. In this task, where the ending criteria are defined, an iterative cycle starts until this final stage is achieved. The cycle calls different subtasks for the agent strategy, the primitives that must each object, and checks if any interaction needs to be activated. Before talking about experimentation, it's important to note that we are only focused on extracting the video game dynamics, in order to be handled by an HTN planner. We have intentionally obviated the generation of heuristic knowledge to come up with plans that solve the video games. Because of that, experimentation focuses on validating the HTN representation of the game dynamics, and not in testing the quality of the plans. For our experiments, we took two puzzle games and two reactive games and visually validated the domain produced. In order to do that, we first defined the templates for each of the elements in those games. We launched the parsing process to obtain the HTN domains with different problems for each game. And finally, we visually validated with the HTN planner and with GVGI that the domains were correctly representing the game dynamics. To do this, we follow the planner state during the execution, testing every part of the domains. For example, we made sure that missiles were being updated each turn, and the interaction were called wherever they were needed. Additionally, we include a handmade strategy for the agent in one of those games, to check the potential on resolving game goals. Here we have a short video of the agent showing how it grabs gems closer to the starting position. Having the basic domain automatically produced, the definition of a strategy is much less time-consuming. Regarding future work, we are considering 3 different possibilities. First, it is clear that this process could be expanded with additional language, from different game representation to other planet language as HTN or SHOP. Offering more possibilities will let the designer choose different planets and language to use. Secondly, as non-determinism is not represented on the domains, and although the use of replanet solves in part this problem, if we wanted the domains to be more self-contained, the introduction of probabilistic planning could be a good idea. And in the same way, we could try to integrate a learner's agent strategy to act and solve video game goals. At present, we are addressing 2 different techniques, one of process mining and a sub-goal selecting architecture. And that's all. Thank you for your attention.